welcome to Solving Quadratic Equations Graphically with Cuba Education. In this mini lecture, you will understand what roots are and know how to solve quadratic equations using these roots. So, what are quadratic roots? We've already looked at quadratic equations. Here is an example of a quadratic equation, x squared minus 3x plus 2. If we solve this, we end up with x minus 1, x minus 2, which means that these two values would need to be multiplied together to give us 2 and added together to give us 3. If you've not watched the video on solving quadratic equations via factorising, which is what this is, please go back and watch that. So this means that minus 1 and 2 would be our roots on a graph. Let's look at the equation again. X squared minus 3x plus 2. If we wanted to plot the graph, we would need a table. So here what I've done is I've done x and I've chosen these x values based on some axes on a graph. So I've just decided to go from minus 4 to 4. So if I put minus 4 as x into my equation, that means I would do minus 4 squared, which would be 16, and then take away 3 times minus 4. Well, it's actually minus 3 times minus 4, which makes 12. Positive 12, actually. So it's 16 plus 12, and then plus 2, which makes 30. We'd then do the same for each of these x values until we filled in the table to give us all of these answers. Again, this is also done on the previous video on plotting graphs, straight line and quadratic graphs. So if you haven't watched that one, go back and do that too. So now we have our table here. Now we've got our table, we have some x coordinates and some y coordinates, so we can add an axis to our graph paper. And we need these values. So I've gone up in 2's, okay, and minus 2's. And as you can see on the y-axis, on the x-axis, sorry, I've only gone from minus 4 to 4. So I only need minus 4 to 4 on my graph. So I've only gone up to 20 because I couldn't fit 30 on. So we'll start with the minus 3. So we have minus 3, 20. So here's minus 2. So this must be minus 3. And up to 20, meaning we need to plot our point there. Minus 2, 12. Minus 1, 6, 0, 2, 1, 0, 2, 0, 3, 2, 4, 6. Now I've also added on the last 2 so that you can see that it's a very nice curved graph that's quite symmetrical. Okay, so that's how you would plot the curve, which we've already gone through on a previous video. The reason I'm showing you this is because I want you to see how it works in terms of finding the, working out the quadratic roots without solving the equation, just using the graph. So here is a graph, and this is a function of x. So a function is just a relationship, like an input and an output of x. So the input is the x coordinate because we add numbers into our equation where x is in order to find the y. So the output is the y coordinate, and therefore shows us the relationship between them. What do we call this shape of graph? If you remember from the previous video, it's called a parabola. So this is the line, the curved line that we have plotted for this equation, just like we did for this line, for this quadratic line, and for what is, if I just go back, this equation. Okay, so looking at this new equation now, we can see that we've drawn this graph. Now, if it's called a parabola, it means that it's going in this nice curved shape like this. The roots of a function like this is where the parabola crosses the x-axis. So here is the x-axis, and here is where the line hits it. So what are the roots of this function? Well, if we go across, we can see that the x-axis, the line hits the x-axis at minus 1 and minus 3. So that is the answer to our quadratic equation. X equals 3. X minus 3 and x minus 1 in brackets. So you've solved the equation without having to factorise it, just by looking at the graph, and you'll be asked to do this in your exam. Okay, if you'd like to pause the video and have a go at this question, according to the graph, what are the roots of x squared plus 8 plus 12? Okay, if you've paused the video and had a go, all we need to do is look at the line, and here is the x-axis. The x-axis hits at minus 2 and minus 6. So that's our answer. Pause the video again and have a go at this one. Okay, if you've had a go, it's asking here for the approximate solutions of the equation, and the reason for that is because it's gone in the middle here. It's not actually on a point, so we have to kind of estimate. But as you can see, it's hit it at 3.5 maybe, and minus 2.5. So here we go, here's our answer. Finally, try this one. What are the approximate solutions to the equation x squared plus 8x plus 12 equals 6? Okay, so for this one, we have to go to where 6 is on the y-axis. The reason for this is because we're given the y-coordinate of 6. Okay, so we go to 6, we go down, and it's like minus 8 something, 8.5, and then we go across all the way to here, and it's about minus 7.2. Yeah, 7.2. Okay, so we're looking at this one just here. So, does a quadratic function always have two roots? So let's have a look at some example graphs. As we can see here, this orange graph doesn't actually hit the x-axis anywhere, which means it has no roots. This graph, this line, hits it just once at minus 2, which means it has one root. And then finally, this blue graph hits it twice at 0 and minus 3. So it has two roots. There is an easy way to work out how many roots a quadratic equation has without plotting the graph, and that will be coming along in my next video on using the quadratic formula. Well done, thank you so much for using Cube Education, and I hope to see you next time.